Okay, so on this question, starting at point A, a ship sails 52 kilometers in a bearing of 190 to point B. Then at point B, it turns, sails 71 kilometers in 276 distance, bearing 276 to point C. At this point, what is the distance the ship has gone? Now, you could do this by drawing triangles, using a lot of sines and cosines and stuff like that. But I'm going to just do vectors. So remember how vectors work? You just do the magnitude or the distance, cosine of the angle for x, and the magnitude or the distance, sine of the angle for y. That's how you do vectors. So I'll do A to B, right? Starts at point A with 52 kilometers. So it's 52 cosine of 190, and then 52 sine of 190, right? That's going to be, goes at a bearing of 190. This is the bearing angle. And so there's that. And then the second part, it goes from B to C. So that's a second vector, second leg of the journey. And that it goes 71 miles, cosine of 276, right? It goes at a bearing of 276, and 71 sine 276. And then it says, what is the distance from where it started? Knows what's the result of these? So we're just going to add these up, and that'll be the result. So whenever you have a couple of vectors, you can just add them up. Add the x with the x. So I'm just going to hit the buttons on my calculator right now. 52. So make sure you're in degree mode. Plus 71. 276, because we're doing degrees here. And I'm getting negative 43.7884, comma. And then I'm gonna add this and this, the y and the y. 52 sine 190 plus 71 sine 276. I'm getting negative 79.6407. Negative 43, negative 79. Let's go make sure my answers are right. Oh, wait a minute. And then it wants distance. Yeah, I didn't finish the problem. I better read the whole question. So now it wants what is the distance? So the distance is the magnitude of that vector. Distance equals the magnitude. Notice how long is this vector? Magnitude of the result vector. So that's what distance is. Distance, if you have, this is the result. So the boat, the ship, went from A to B, this far x, this far y, then B to C, this far x, this far y. Add that up. Here's the result. But they want the total distance of that vector, which is the magnitude of a vector. Remember how we do the magnitude of a vector? That is the square root of x squared plus y squared. This is x, this is y. So that'll be the square root of negative 43.7884 squared plus y, which is negative 79.6407 squared. All right, hit the buttons on your calculator. Whoops. There. So I'm going to do the same thing. Squared. And I'm getting 90.8849. Is that what it was? 90.8849. Yep, beautiful. So there it is. So that's how we find the overall distance that the ship traveled. So again, we could have done this with drawing triangles and using a lot of sines and cosines, but vectors are nice and easy. This was easier, wasn't it? No no angles, messing around. You just say, look, it's two vectors. The ship goes from A to B, and then the ship goes from B to C. So A to B, you just take the magnitude, which in this case is the distance, times the cosine of the angle, magnitude times the sine of the angle. Same thing for the second vector. Add them together to get the resultant vector, the x and the y. Then if they want the distance, that means they want the length of this vector, right? This vector is back x down y. They want the length of that vector, the total distance, magnitude square root of x squared plus y squared, right, from the Pythagorean theorem. And there we go, total distance of that vector.